Hi students, welcome to the science class. In last session, under the chapter of metals and nonmetals, we discussed about some of the chemical properties of the metals and nonmetals, isn't it? That's are nothing but how the metals reacts with the air, how the metals reacts with the water, and also we discussed how the nonmetals reacts with the air and how the nonmetals will react with the water also. And today's session we are going to discuss the continued part of that session, that is nothing but the reaction of metals with the acid. So it is also one of the chemical property of the metals, how the metals reacts with the acids, and also we are discussing here the reactivity series of the metals, how the metals can react. That will we are going to represent that metals in terms of a series, by the decreasing order of their reactivity with the acids. And another one thing is the reaction of the metals with metallic solutions with the another metallic solution. So now I am going to start the session with the reaction of metals with the acids, how the metals reacts with the acids. See here, when any metal reacts with the acid, it produces its metallic salt with releasing of the hydrogen gas. When any metal reacts with acid, it produces a salt of metallic salt and it releases hydrogen gas. Any metal that will be reacts with the acid, that releases the hydrogen gas. So I am telling one activity here. Take 4 test tubes. Take 4 test tubes and pour about 5 to 10 ml of the dilute HCl solution in the test tube. You have to pour dilute HCl solution about 10 to 15 ml of the dilute HCl solution into the test tube, and you have to put the samples of the metals. Take ferrous iron metal, magnesium metal, zinc metal and aluminum metal. You have to place the samples of the metal into that 4 different test tubes, and also you have to insert the, that is I am going to refer, you have to insert here so what it is, you have to insert the pieces, that is samples of the metals into the test tube that containing hydrochloric acid, and you have to simultaneously note down the temperature of that solution. You have to remember, you have to clearly observe here, when you are going to place the metals into the dilute HCl is an acid, so metals reacts with the acid and small bubbles are going to become in the test tubes when you are going to place the metal into the acidic solution or in the acid. So some small bubbles are all coming here, and also there is a rise in the temperature. You have to observe very clearly. You have to keep that thermometer in all 4 test tube in a such a way that the tip of the thermometer just, or the bulb of the thermometer just inside the solution, inside the acid. You have to place that thermometer in a such a way that bulb of the thermometer just inside that acid. And now you have to observe the change in the temperature of the solution after you have putting that metal into that all 4 test tubes. So here the temperature rises in all the conditions. Why? Because when metal reacts with the dilute acid, it releases the hydrogen gas. So when hydrogen gas is released, this is an exothermic reaction. Therefore here the heat will be produced. You already know that what is exothermic reaction. In any reaction, if heat will be evolved, that type of reaction is called it as a exothermic reaction. So the metal when reacts with the dilute acid, it is an exothermic reaction. Therefore here the heat will be evolved. So when you are going to check the temperature of that solution, so somewhat the temperature will be increases here. You have to note down the temperature of all metals here. Based on this temperature, we are going to write down the reactivity series here, how the metals will be reacted. So first I am taking one example here. When ferrous reacts with the dilute hydrochloric acid, so when ferrous reacts with the dilute hydrochloric acid, it produces the ferric chloride as a salt, and it also releases hydrogen gas. So another one example, when magnesium reacts with dilute hydrochloric acid, it makes the salt of magnesium, that is magnesium chloride, and hydrogen gas will be evolved here. And also when zinc reacts with dilute hydrochloric acid, zinc chloride will be formed, that is as a salt, and hydrogen gas will be evolved. So when any metal reacts with the acid, it produces the salt and releases the hydrogen gas. But you have to remember here, the copper does not react with the dilute HCl. So it is reacted with the sulfuric acid. Copper doesn't react with the HCl, hydrochloric acid, but it can be reacts with the sulfuric acid, that is concentrated H2SO4. It is one of the exception here. The metal copper doesn't react with the acid called a dilute hydrochloric acid. It reacts with the sulfuric acid. So from the temperature we come to know that the test tube which has high temperature, that is more reactive here. Based on the temperature, we are going to write here the reactivity series of the metal. What is reactivity series here? The reactivity series is nothing but the arrangement of the metals in a decreasing order of their reactivity. What is reactivity series? The arrangement of the metals based on their decreasing order of their reactivity is nothing but the reactivity series. So the potassium, sodium, calcium, magnesium and aluminum, these are all more reactive elements, therefore they come at the top of the reactivity series. And the zinc, ferrous, lead and copper, they are medium reactive metals, so therefore comes in the middle part of the reactivity series. And here mercury, silver and gold, these are less reactive and they come at the down part of the reactivity series. So what is reactivity series here? This is the arrangement of the metals based on their decreasing order of their reactivity. Here these are less reactive, these are medium reactive and these are more reactive. You have to remember here one point, I am very important point I am telling here, that is aquaregia. This aquaregia, it is a mixture of concentrated HCl and the concentrated HNO3, that is nitric acid. The aquaregia, it is a mixture of concentrated hydrochloric acid and the concentrated nitric acid that will be utilized for to convert the solid gold into molten gold. That will be molten, that the gold will be molten with the help of the aquaregia solution. You have to remember the aquaregia is used for to molten gold, to melt a gold. So we use the solution called aquaregia. That aquaregia contains, that is concentrated hydrochloric acid and concentrated nitric acid. So in villages there are some of the persons are coming for your home to wash the golden items, and they told you that to make that golden items too much brighter, so don't give that golden items to that persons. Why? Because they are using aquaregia. They are going to melt your gold and they rob your gold. So you have to be careful here. The aquaregia, it is one of the solution made by the concentrated hydrochloric acid and the concentrated nitric acid. It will be melt the gold. So that is another one important thing here. But why I told here, because what I told, when any metal reacts with the acid, that produces the salts and hydrogen gas. But in the case of the gold, it not produces the salt and hydrogen gas, but it melts the gold. Therefore it is very important here that solution, it is nothing but aquaregia. And this is the reactivity series. And now I am going to consider another one important thing here, reaction of metals with the solutions of other metallic solution. So how the metal reacts with another metallic solution. Consider two test tube here. Pour in one test tube as, that is copper sulfate solution. You have to pour copper sulfate solution in one test tube, and another one test tube we have to pour ferrous sulfate solution. In one test tube you have to pour copper sulfate solution. In another one test tube you have to pour ferrous sulfate solution. That is, test tube A contains copper sulfate CuSO4 and test tube B contains ferrous sulfate, FeSO4. Okay, so the copper sulfate solution is basically blue in color, bluish in color. Now you have to place a iron nail into the copper sulfate solution. You have to place a iron nail into the copper sulfate solution, and you have to place a copper nail into the ferrous sulfate solution. You have to clearly observe here, the copper sulfate solution is bluish in color, but when you are going to place a iron nail into the copper sulfate solution, that color of the copper sulfate solution turns to brown. The color of the bluish color of the copper sulfate solution will be faded out and it will be turns to brown color. Why? Because what happens here, that is due to the reaction of the metal with the other metallic solution. Here the CuSO4, it is a metallic solution, the iron is a metal, that metal reacts with the metallic solution. But in the case of the FeSO4, that is ferrous sulfate solution, the copper nail doesn't make any difference here. Why? What happens here? What is the case? What is the reason behind that here? That will be studied now. So when any metal reacts with another metallic solution, what happens here? The higher reactive metal replaces the lower metal from the metallic solution. So when Fe, that is iron nail, reacts with the copper sulfate solution, this iron displaces the copper from the copper sulfate solution. So that is nothing but the simple displacement reaction. Here the simple displacement reaction happens. What happened here? The higher reactive metal replaces the lower reactive metal from the metallic solution. When any metal reacts with a metallic solution, a metal which has higher reactivity or a higher reactive metal displaces the lower metal from the metallic solution. So one example here, so general example, when metal A will be react with salt solution of metal B, the metal A will replaces the metal B from the salt solution of metal B, and that will be forms salt solution of metal A plus metal B. So one example here, when a copper sulfate solution reacts with the iron is the more reactive than copper, so therefore iron displaces the copper from the copper sulfate solution and it forms ferrous sulfate solution plus copper. But the reverse reaction, it is not possible here. Why? Because this copper is less reactive than the iron. So if you are going to place the copper nail into the ferrous sulfate solution, there is no change in the color. That brownish color doesn't change to blue. Why? Because here the copper is less reactive than the iron, therefore there is no displacement reaction. Once again I am repeating here, when any metal reacts with the other metallic solution, so that metal displaces the another one metal which is present in the metallic solution, if and only if the metal is more reactive than the metal which is present in the metallic solution. That is nothing but the simple displacement reaction. When ferrous reacts with the copper sulfate solution, the iron is more reactive than the copper, therefore iron displaces the copper and it forms ferrous sulfate solution plus copper. So when any metal reacts with a metallic solution, it displaces the metal from a metallic solution. So one question comes in your mind, why the metal will be more reactive here? Why it will be reacts with other metals? So that is nothing but reaction of metals with the non-metals. Why metals is so reactive here? Why they are going to reactive? That is nothing but reactivity of the element is the tendency to attain a complete filled valency shell. See here, why the metals are so reactive here? Yes, that question will be arises in your mind. But why it is more reactive? Because always a metal, it has a capacity, it tends to always to attain a completely filled valency shell. It always to get a stability by attaining the complete filled valency shell. So I am considering here sodium, it is the most reactive here. The sodium with the atomic number 11. So when you are going to consider the electrons which are present in the shells K, L, M, N, based on the 2n square rule, we are going to fulfill the electrons here. So for the first cell, I am filling 2 because the number of the cell is 1, therefore 2 into 1 square, that is 1, that is 2. Therefore I am filling only 2 electrons here. Next, remaining in the 11, that is 9 electrons are remaining here. In the second orbit, that is L, 2 into 2 square, I am filling, that is 2 into 4, that is equal to 8. In the L subshell there is 8 electron, but the remaining 1 electron will be in the M shell. So M shell, the capacity of the M shell is 2 into 3 square. 2 into 3 square, that is 3 is 9, 9 into is 18. If 18 electrons are present in the M shell, then it will be, the valency will be fulfilled, that it attains the completely filled orbital, then it is not react with any other metal. But here only 1 electron is present, that is, it is half filled, isn't it? It has the tendency to give 1 electron, or it has the tendency to accept, it has a tendency to accept 17 electrons or 7 electrons. We know that octet rule. If the outer subshell contains 8 electron, then that metal and element will be, that is stable element. If the outer shell, that is here M is the outer shell, if the M contains 8 electrons, then we are going to call it as an stable element. But here it doesn't has 8 electrons, or it doesn't has 18 electrons, it has only 1 electron here, that is its valency is 1. Why? Because the free electrons will present in outer subshell, that is 1. Therefore it has the tendency to give this 1 electron or accept 7 or 17 electrons. Therefore it is more reactive. Why the metal, the sodium, it is more reactive? Because it has 1 electron, that is 1 free electron in its subshell. Therefore it is more reactive. Always atoms of the metals lose electrons from their valence shell to form a cation. Always any metal you are going to take here, metals always has a free electrons, therefore they have the tendency to lose the electron to attain a stability. Therefore atoms of the metals lose electron from their valence shell to form cation, and atoms of the non-metals gain electron in the valence shell to form an ion. So when these non-metals always accepts the electron, but the metals always lose the electrons. Therefore atoms of the metals lose electrons from their valence shell to form cations. Cations here, that is the ions which are represented by the positive symbol. Cations means they always give the electron from their atom, because the metals has 1 free electron in the outer shell. I am considering here sodium, it has 1 free electron here. Again you are going to take any metal here, the metal which is more reactive, it has some of the free electrons in the subshells, therefore it is more reactive with the other elements, or it is more reactive with the non-metals. So the metals have the free electrons here, therefore it reacts with the non-metals. So metals have the free electrons, they have the tendency to give the electrons or lose the electrons, but the non-metals it has the tendency to gain the electrons. Therefore metals are called it as a cations and non-metals are called it as a anions. Metals are always have the tendency to lose the electrons, and non-metals are always have the tendency to gain the electrons. For example, one example taking here, the sodium has the tendency to lose 1 electron, and chlorine has the tendency to accept 1 electron, because if it accepts 1 electron, the subshell of the chlorine or the subshells of the chlorine atom, it will be fulfilled and it will be stable. Therefore by accepting 1 electron from the sodium, the chlorine will forms NaCl as the compound, that is a stable compound, that is called as a sodium chloride. So the compounds which are formed by the sharing of the electrons, the compounds which are formed by the sharing of the electrons are called it as ionic compounds. What are ionic compounds? The compounds made by sharing sharing of the electrons are known as ionic compounds. Ionic compounds. Why? Because it is called as ionic compounds, because we are calling the metal as a cation, and anion, chlorine as an ion. By sharing the ions are nothing but electrons, therefore it is called it as a ionic compound. That is ionic compound. What is ionic compound here? The compounds made by sharing of the electrons are known as a ionic compound. So here the sodium shares, it loses one electron, it loses one ion from the atom there, and chlorine accepts one ion from the sodium, therefore NaCl, it is an ionic compound. Then what are the properties of the ionic compound here? First I am considering here the physical nature. What is the physical nature? The physical nature of ionic compounds. Ionic compounds are generally hard, and brittle. The physical nature of the ionic compound is the ionic compounds are generally hard and brittle. And what is the melting point and boiling point here? The ionic compounds are always has high melting point and boiling point. This is the another one property of the ionic compounds. So another one property of the ionic compound here, that is melting point and the boiling point. Generally the ionic compounds has high melting point and a boiling point. And what is the solubility here? The ionic compounds soluble in water. Ionic compounds soluble in water but insoluble in solutions like kerosene. Generally these ionic compounds are soluble in water. When you are going to put the sodium chloride, that is a common salt, what we are going to call it, will be soluble in water, but this sodium chloride, it is not soluble in the solutions like kerosene. That is the another one physical property, that is solubility of the ionic compound. And conduction of the electricity, how it works. So ionic compounds doesn't conduct electricity in a solid state, but it conducts current. It conducts the current in molten or liquid state. What it means here, that is another one physical property of the ionic compound here. The ionic compounds doesn't conduct the electricity or doesn't conduct the current in the solid state. It doesn't conduct the current, but it conducts the current in a molten or liquid state. That is the solution of the the solution of the ionic compounds conduct the electricity. So another one physical property that it says here, the ionic compounds doesn't conduct the electricity in a solid state, but it conducts the current in the solution or in a molten state, that is in the solution of the ionic compound conducts the electricity. This is all about the chemical properties and the physical properties of the metals and non-metals here. But one question arises in your mind, how we are going to get the metals, where we are going to get the metal? So we get the metals from the minerals, and we get the metals from its ores, isn't it? But what is meant by mineral here? What is meant by ore here? So minerals are nothing but the elements or compounds which occur naturally in the earth crust are called minerals. The elements or compounds which occur naturally in the earth crust are called it as mineral. So once again I am repeating here, we get the metals and non-metals from the earth crust by the minerals. So what is minerals here? Minerals are the elements or compounds which occur naturally in the earth crust are called it as minerals. And what is meant by the ore here? Ore are the minerals. These are the minerals that contain very high percentage of the particular metal. For I am considering iron ore. Why we are going to call it as a iron ore? I am going to not call it as an iron mineral. I am going to call it as an iron ore. Why we are going to call it as a ore? Because if the mineral contains very high percentage of the particular metal, you have to remember here, the mineral doesn't contain only one element. It contains many number of elements it has many number of elements. But when we are going to call it as a particular ore, for example I am taking iron ore, when I am considering iron ore, it doesn't contains only iron here, but it contains any other elements. But why I am calling it as an iron ore? Because the mineral has a high percentage of the iron, therefore it is called it as a iron ore. So once again I am repeating here, what are ores here? The minerals that contain very high percentage of the particular metal, that is called it as a ore. So in the today's session we discussed about what the some of the chemical properties, that is how the metals reacts with the acids, how the non-metals reacts with the acids, and also we discuss the what are the characteristics, what is meant by the ionic compound, what is reactivity series, what are the properties of the ionic compound, isn't it? And also where we get the metals and the non-metals. But in next session I am going to discuss with you how we are going to extract the metal from the ores, how we are going to extract the pure metals from the ores. That will be discussed in the next session. Thank you.